So good morning, everyone. Today I'm presenting the solution of the homework 5. I'll start with the first question, which was about the k-means algorithm. So we are provided with a set of nodes. In fact, you have 10 nodes and you have their coordinates here in this matrix A. And what we are looking for is are the components of the two clusters, P and Q, such that we would minimize the total sum of the squares of the distances of from the centroids of each cluster to the components of each cluster. So you have two clusters P and Q, and this formula, in fact, will give you this objective. Okay, so what we were provided with a hint, the kind of algorithm to follow. So I'll start with the initialization. In fact, I'll start initially with two clusters, clusters P and Q, and in every iteration here, I'll put and add a node to my cluster, following the steps of the algorithm. So I'll write down here. I'll say that these are the iterations. Okay. And I'll start with iteration 0. So for iteration 0, I'll write down here in this part, I'll give let's say the coordinates of the centroid. So this is CP and this is CQ. He will have, the centroid will have two coordinates, of course, X and Y. I'll put them here. Okay, and here I'll list the components. Okay, so I'll start with the first initialization. So here I'll have just here in my set of nodes in P, and here this is the set of nodes in Q. And so I'll say that here I'll start with node 1 in P and node 10 in Q. Why is that? I can always check that these two nodes are maybe the furthest from each other. So I'll just take the furthest points and pick them as seeds to each one of the clusters. So what are the coordinates of these 2 points? Of course, for us, node 1 has the coordinates 2, 2, and for node 10, the coordinates are -2, -2, okay? And I'll move on to the next iteration. Now I'll start iterating. So what is the purpose? The purpose is now to add the node which is the closest to each one of the clusters. So for the centroid of P, the closest node here is 2. So you basically get node 2, which would be added, 1, 2. And if you update now the centroid coordinates are going to be 1.5 and 2. Okay. Now I'll add to node 10 in Q, add node 9, which is also the closest. Okay. At some point, you may have 2 or 3 possibilities, but they will land the same result. So I'll update also the coordinate of the centroid here, which is -2, -0.5. I'll double this line to understand that here we have two different clusters. Now, for the next iteration, I'll add the closest to the centroid, which is going to be node 3 here, and I'll update. So I'll have the new coordinates. Okay, it's quite easy to obtain. Well, you can sum up all the x's and the y's and divide by 3 now. And here for the next cluster, we'll have 10, 9, and 8. And I will update. So now my coordinates of my CQ are -1, 67, -1, 67 also. Okay. Now, the next iteration, I'll add a 4th node to cluster P. So I'll have node 4 also to be added. Okay. I'll update the centroid coordinates. So I'll have 125, 125. So it's easy to check. You can sum up all the x's here you have 5 divided by 4, and here also 5 divided by 4. And similarly, I'll do with the Q. So I have 10, 9, 8, 7, which is the closest to the centroid of Q. And I'll have this, so I'll have minus 0.5, minus 1.5, and minus 1.5. Now, only 2 nodes are left. So the best one to add to cluster P is 5. It is the closest to the centroid. Okay, and the node 5 has the coordinates 0, 1. So I'll end up with the centroid coordinates here, CP 1, 1.2. Okay, and for cluster Q, I'll add, of course, node 6, and I'll update. I have negative 1.2, negative 1.2 as the 2 at the center. So overall, if you sum up all the distances, you will get that this part here for these two clusters is equal to 4.8, and this part is equal to 5.6. So you end up with a total of 10.40 units, which is the 2 means solution to our problem. Okay, so I'll come back with in a few moments with the second video, which shows how to perform a minimum cut cluster. Thank you.